This video is going to be about variables. Now, this will be how you design scientific tests and things like that, and how you plot graphs as well. And most of my students do find troublesome graphs hard, so this is a good one to watch. Imagine you want to conduct an experiment and you want to measure how much of the sunlight affects a plant's growth. Well, you need to think of a certain number of things. What variable are you measuring? So it's going to be centimeters probably of the height of the plant, something like that. What are you varying? Well, you're varying the sunlight. Okay. What other factors might affect the experiment? It's the amount of water, for example. Okay, so if you're doing different experiments, you've got to give the same amount of water. Okay, and is it fair to let more than one variable change? No, it's not. So you change one variable, and then you know that whatever you change is going to be is what affects the plant's growth. Now, those variables, the names of these variables are called independent. So the one you're changing, okay, is this one, independent. The one you're measuring is dependent. Okay, and I'm going to share a little acronym with you. It's called In Class Don't Mess. In Class Don't Mess. In stands for independent, and I'll say it probably 10 times before the end of this video. So in class, IC, independent, change, dependent, measure. Okay, so let's do this. Independent, in class, independent is the one you, in class, IC, independent is the one you change. Okay, so the one you control, change, whatever you want to call it. Now, so that means basically you're testing the amount of sunlight. The amount of sunlight is the independent variable. It's how much you're actually exposing it to. Now, dependent variable. Dependent one is the one you measure. Okay, and that, for example, can be the height, number of leaves, all this kind of thing. But anything that you measure. Remember, in class, don't mess. Dependent is the D, and measure is the M. Okay, so in class, don't mess. The third type of variable is control. That's the one you keep the same, okay? So in this experiment, you would keep the type of plant, the amount of water, type of soil, all temperature, and all that kind of stuff. So you've got to be used to saying what is the thing you keep the same. Remember, in class, don't mess. All right, so if we then look at collecting the data. Data should always be collected in a table, and the table must have a heading. Use a ruler and pencil. The x-axis is the independent variable when you do the graph, and the y-axis is the dependent variable when you do the graph. Okay, but they usually should be the first column and the second column in the table. If there are units, you put them in the column heading. Okay, so you put them in the column heading, and then you don't have to rewrite it over and over and over and over and over again. Be consistent with a number of decimal places or significant figures. So usually at this stage, it's decimal places. So always give 1 or 2 decimal places in what you're doing. So here's an example of a good table. Can you see that the heading here, you can see it's seconds, so I don't have to write seconds all the way down. You can see it's centimeters cubed, so I don't have to write centimeters cubed all over again. Okay, and the volume of CO2 is what I'm measuring. So in class, don't mess. This is my dependent variable, okay? And then it says here, table to show the volume of carbon dioxide realized over 3 minutes by the reaction of 2 grams of marble chips with hydrochloric acid. Okay, so I've only done one experiment here, so there's nothing I'm really changing. There's nothing I'm really kind of deliberately changing. Okay, so on this graph, I would usually put time because I'm only really doing one experiment. I do time, and I do volume of CO2. Now also, a good thing to notice, and we'll talk about this at the end, is that they're numbers. Therefore, this is a line graph. And we'll talk about that later and show you later on. So let's talk about graph plotting. Results are best displayed in a graph that trends and patterns can be determined. So basically, we're going to look at the trends and patterns at the end of this. Bar charts, when it's not a number, and it used to be called categoric variables. So if it's a categoric variable, then you basically draw a bar chart. Best fit graphs, okay, scatter graphs. Scatter graphs are just when you've got loads of dots everywhere. And we don't really do those in science. We do best fit graphs, okay? When you draw a line of best fit. And I'll show you both of those now. Okay, so you need to make sure you know what goes on the horizontal and what goes on the vertical. Remember, on the horizontal is your independent variable, and on the vertical is the dependent variable, the one you change. So you work out a scale for each axis, and the scale must be more than half the axis. So basically, it must fill more than half the paper. and you must choose the scale to fit. Okay, and so you just look at the squares and see how many you can square. And I think it's nice to usually to have one square versus usually a tenth of one. So basically each set of 10 squares is 0, 1, 2, 3, 4, or 0, 2, 4, 6, 8, or 0, 3, 6, 9, 12. Okay, and it's best to do it in pencil. Label each axis with the names and the units. Really important you do that, the name and the units. Do this in pen and plot the points using a cross. Okay, really important. Lots of my students do it with dots. Don't do it with dots. I get very angry if you do it with dots. Do it with crosses. Anyway, so let's go to the next one. If there's a clear pattern, draw a line, a single line, best fit line, curved or straight. None of the like ones that go. Don't do that. And draw it in pencil just in case as well. You can rub it out and you can start again. So let's do 2 examples, right? So here's one. What do you think this is? Okay, I'm going to try and draw it on here. It won't be 100% accurate because I'm drawing on the board. Okay, but look at that. What are you going to draw? First important thing is it starts from 0. We've got a point here, so it starts from 0. It's good. And most of the time at your stage, it will start from 0. So I'm going to try and get it accurate here. Believe me, I'm doing it on the board, so it's not going to be perfect. Okay, and so basically come up here. It's a nice smooth line. Okay. And there you have it. Okay, bit not smooth as I'd like, but you know, nice. Okay, can you see it's nice? You see there's no anomalies here. There's no anomalies, and I'm going through most of the points, and if I'm not going through the point, there's the same amount of points either side-ish. Okay, so that would be a nice line of best fit. And this is the style you'll normally see in chemistry most of all. Okay, and I'm going to show you one more in a second. So here is our second one, and we've already drawn the line on here. Okay, so you can see here, again, really nice graph. We can see we've got the units, we've got the time, we've got the minutes. It's all good. And we can see this one is a little bit less ordered than the other one. You can see that the line is not really going through any of the crosses. Okay, it goes through the cross at the end, maybe, but the most important thing is that there is the same number of each cross on each side, roughly. Okay, it doesn't have to go. Do not draw a line that goes dunk, 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 dunk. Lots of people at your stage do. Okay, just draw a line that roughly fits the points, has roughly the right number. And you need to practice this quite often because it takes a bit of practice getting the right amount of number of points on each side. Okay, right, so this is the end of our video on plotting and doing your tables. I hope it helps. Please like, share and subscribe. Okay, and please let as many people get a use of this video as possible.